channel. Here is the deal. This is application I wrote some while ago. This is an example of neural style transfer, so-called. Initially I wrote it with C++ and the OpenCV framework, which stands for Open Computer Vision. So, and in the beginning it was so slow. Now it's more or less responsive, even it doesn't block UI. And so the OpenCV initially it uses like software rendering and acceleration basically, so the performance not that great. And I was looking for different ways how to accelerate the solution, and yeah, I went through some hops and tried compile with OpenCV with CoreML, didn't help, but use actually ONNX backend since I used ONNX model. So I downloaded again ONNX runtime and I had to compile with runtime again with CoreML support, and finally I came down to the pure CoreML solution. So just a quick overview, and this is application. You can choose different models. One is pre-trained, it's called Mosaic, which you can see on the screen at the moment, but I trained by myself different ones. Matrix, Blue, Green, and Austin Powers I trained by myself. So I just want to discuss a little bit performance side. So as we can see, there's different configuration how you can offload the workload to different compute units on Mac. So they have like a standard configuration is like you can use all compute units. That means you can utilize like CPU plus GPU plus NPU, ANE actually it's called in Apple's ecosystem. And also you can do any combination of, like, for example, CPU and GPU, CPU and NPE, NE. This is a kind of relatively new option, in fact. So yeah, and eventually I encountered like NE is not utilized, as you can see, as much. Mainly it's CPU and mainly it's GPU, in fact, and a little bit of CPU. And NE max size, so like 9% here, maybe 10, I don't know, 10 even I didn't see. So yeah, I think Apple needs to do some improvement around this for sure. And yeah, even during training of these models, Apple doesn't use its own neural process units. So if you, for example, I close this application and I show you how I trained the models, and for example this one, if you can see this utilization now is okay, more or less. GPU is not loaded in E0. E-cores working on something, and I'll try to give it 20 more training iterations and see how the performance is going to handle it. And as you can see, yeah, mainly they utilize CPU and little bit of GPU and no NE at all. So I don't know why, but it makes sense to utilize the NPU as well, but somehow Apple's limit this, or there is no support yet or they out of hands. I don't know what's going on Apple side, but definitely should address these problems. Yeah, in fact, if Apple addressed these problems, performance would be so much better. I'll show you, for example, if I use like particular this configuration like CPU and NPU, how will performance will look like. You will be surprised. I'll stop the training. Check the graphs. Pausing. Pausing. Hopefully pausing. Okay, paused. So okay, graphs get little better. Yeah, let's try that. So you see prediction time got much higher, like 1 second, even 2 seconds. Okay, average maybe 800, 900 milliseconds. That actually very laggy, in fact. And it's NPU and CPU, as you can see, NE is not utilized, in fact. Very strange. But CPU fully utilized, and even GPU a little bit. So I think the best combination so far for me was somehow this combination of CPU and GPU. If we start, yeah, as you can see, it's very responsive. And yeah, prediction time around, it was around 200 something. Yeah, now it's stabilized. Yeah, somehow much faster this CPU and GPU combination. And yeah, apart from that, there's also some other tricks I used. Async execution in the ML core ML support, basically synchronous, asynchronous, and batch predictions, as you call it. And yeah, if you want to block your main thread, so use async. But if you don't want, use async. It will utilize some internal queue and some thread pool maybe. And batch, of course, it's more like for training or like series of data that you don't use in runtime, in real time, I think. So I think is the best solution, in fact. And yeah, you can swap resolutions. And also there was I used different tweaks with the model, of course, because standard models, they have a fixed inputs shape, so I need to tweak that to make it flexible. This is full HD, by the way. Little laggy, but still responsive. In fact, it was much better than in the beginning. Okay, I'll show you how it was in the beginning. 1 second. was like that. If we stop comment out here, and it's not Control Shift, right? And we need, of course, to uncomment this line, and this is initial solution, like that. This is basic OpenCV approach with DNN model. Still it's laggy. It's a synchronous C, like it's like 2.5, 3 seconds. Terrible. And of course it's blocking everything in the FPS. Terrible. And yeah, my laptop is on power, will die. So I tried to make it async by using Threadpool and the queue. So let's see how it looks. Just 1 second. Image. I need an image too. Right? Alright, so let's see. Yeah, it has a delay. So basically 5 seconds delay before it starts processing. 3, 2, 1, go. Go. No. 24. Yeah, actually quite a long delay, but at least it doesn't block the UI. Strange why it's so slow. Wow. I think it got even worse, man. Alright, I need to look into that why. Sometimes it's get faster, sometimes no. Very inconsistent. Alright, I'll close that. See, okay, I think that's all I wanted to say. Yeah, if any comments, just leave it anywhere on my site or YouTube channel, whenever you prefer. And yeah, click a like and subscribe. See you later. Bye bye.